Hi everyone, nice to meet you. It's a pleasure to participate in another EPIC conference. I'm Isabella, I'm a chemist, and nowadays I'm PhD student at EPIC. I would like to discuss with you the effect of the demulsifier on water-oil interfacial properties and emulsion stability. Let's start talking about emulsion formation in oil field. During oil production, oil and water are vigorously mixed when passed through some spots with high shear and high turbulence, like, for example, choke valves or centrifugal pumps, leading to emulsions which remain stable for a long time due to the presence of some natural surfactants like asphaltenes, resins, or naphthenic acids naturally present in crude oil. When this kind of emulsions are formed, emulsions can impact the oil production because fluid viscosity increase, decrease of pump performance, reduction of lifting capacity per stage, increase the power energy consumption, and other problems. Therefore, it's totally necessary to apply some treatment to break the emulsions, and treatment with chemical demulsifier are usually applied generally in all crude oil production systems around the world. The selection of the emulsifier for field application usually is based on bottle test technique, which is based on trial and error, and usually spend a lot of time to perform, and it's not so good. Okay, my research was based on 8LD concept, which means hydrophilic lipophilic difference. The formula of 8LD is composed by some variables like salinity, characteristics of oil, some co-surfactant like some alcohol, characteristics of surfactant, and temperatures. And all these variables can affect the stability of emulsions. Based on these 2D diagrams, which correlate interfacial tension with ADLD and stability of emulsions with ADLD, we can take some important information from these diagrams, right? So, as you can see, a minimal interfacial tension occurs when ADLD is equal to 0, and a minimal emulsion stability occurs when ADLD is equal to 0 again. So based on that, the hypothesis of this research was created. The demulsifier efficiency couldn't be correlated with interfacial tension measurements through 8LD concept, which means we hope the most efficient demulsifier couldn't be able to lead my system near to ADLD equal to 0, which means a minimal interfacial tension and minimal emulsion stability, consequently achieving the phase separation. Therefore, the motivation for research is establish a criteria for development and evaluation of demulsifiers for field application. And the main goal of this research is to evaluate the interfacial properties of water-oil systems as a parameter for selecting the most efficient demulsifier applied in the field, like an alternative to looking for some efficient demulsifiers, right? And like an alternative for exhaustive bottle test technique, okay? And now I'm going to talk about the methodology. So I worked with two different systems composed by heavy crude oil A and its produced water, and have crude oil B and its produced water from the same field. And interfacial tension was performed by a spinning drop tensiometer like this one. And the sample preparation starts by placing a little drop of the oil inside right, the capillary, and then filling this capillary with a denser phase of emulsion, which is produced water. And then I inserted this capillary in a temperature controlled here and applied some in a specific rotational speed and got the interfacial tension measurements until achieve the interfacial tension in a dynamic equilibrium. To evaluate the stability of emulsions, I made some analysis based on bottle test. We established a 15% of water cut for all systems, for all emulsions. First of all, oil and water were dispersed by a two hux forming water-oil emulsion, stabilized. And then I added a certain amount of demulsifier on my system, stirring again. And the emulsion were centrifugated for 1 hour until achieve the phase separation. And I'd like to say we used the centrifugation just to improve the phase separation, because my water oil emulsions was very stable, and then was very difficult to achieve phase separation naturally. So was necessary applied some centrifugation, right, to improve this phase separation. And here some parameters that I'm using, I use it in my analysis: the emulsifier concentrations and temperatures, and I repeat the same parameters for interfacial tension measurements. And to evaluate the emulsifier efficiency, I calculated the separation factor R. R was calculated by mass of total water separated and mass of total water inside that I put on emulsion at the beginning, okay? And now I'm going to show you some results that I got in my research. So first of all, analyze the temperature effect on interfacial tension for systems composed by oil A and its produced water, and oil B and its produced water. First of all, interfacial tension for systems without the emulsifier, black line here, was much higher than the interfacial tension with the emulsifier added, right? And we can observe this result for both systems here. And again, for both systems, we can observe a trend, which is the interfacial tension increased with the increase in temperature, and here again as well. And looking for some explanation, I worked with ethoxylated demulsifier, and its solubility can be changed. Sorry, its solubility can be changed by temperature. As the temperature increases, the demulsifier becomes more soluble in oil than water, and then decreasing its efficiency at the interface, and consequently decreasing its efficiency in the demulsification. And then we can observe the interfacial tension increasing. And here we have the effect of the demulsifier concentration on interfacial tension for systems composed by oil A and oil B. And for both systems, we can observe a trend, which is the interfacial tension decreasing by the emulsifier concentration increasing and here as well, okay? And this result could be explained by some molecular rearrangements occurring when we add the demulsifier on system. Like when we have a higher concentration of the emulsifier's molecules are able to to displace natural surfactant adsorbed at the interface, and then reducing the stretch of the interfacial film and reducing the interfacial tension as well. Consequently, leading the system to a phase separation instability, right? And here I have an important result for this research. I analyzed the relationship between the interfacial tension and separation factor R under the effect of different concentrations of the emulsifier and temperatures. And first of all, analyzing a system composed by oil A and its produced water. For systems composed by oil A and its produced water and all analyzed temperatures here, we can clearly observe a trend, right? So we can see the separation factor increasing, right? With interfacial tension decreasing for all temperatures analyzed. And the highest separation factor was achieved in the highest demulsifier concentration and temperature. And the same trend here for systems composed by oil B and its produced water, the same trend was observed. As you can see clearly, we have the separation factor increasing with the demulsifier decreasing, right? For all temperatures analyzed again. So this result suggests that the demulsifier proved to be efficient, which means the demulsifier was able to reduce the interfacial tension, right? Leading to the system near closer to 8 Lg equal 0, taking the emulsions to a region of instability and achieving the phase separation consequently, okay? Therefore, the conclusions. So the results suggest that the interfacial tension can be used as a parameter for the selection and also the development of efficient demulsifier. The result indicate an inverse relationship between the interfacial tension and separation factor, as we saw. Therefore, the interfacial tension values showed to be a good parameter and an easier way to predict the demulsifier's efficiency through laboratory tests, which means better than exhausted bottle test analysis, okay? Usually applied to select the emulsifier. So I would like to thank for all support that I have been receiving from Unicamp, Equinor, FAPESP, ANP, CEPETRO, FEM, especially support that I receive every day from my group, Alpha Group, right? Composed by important people who makes it happen so good. So thank you all, and thank you all for listening. Bye.